Hey, welcome back. Today I'm going to be going over this SAT constant question. And as always, right, thanks for Anico.ai for providing this specific question in their free resources tab. But before I get started on the explanation, please give this a try yourself. Okay, so here we have two functions given, right, where p, q, and r are constant and they're integers. It tells us if this equation is true, right, which choice is the value of p. Okay, so assuming you have actually looked at the problem by now, you'll notice what's tricky about this question is that not that there's a lot of steps involved, but rather there's three constants. There's p, q, and r, right? And well, how are you going to find the value of one constant, p, if you don't know what these other ones are, right? But the thing to notice is don't actually focus on what they give you here. Look at this specific equation, right? You're going to use this at some point, but the key thing to look at here is that you're multiplying two functions together, and that gives you this expression, right, with no constants, right? And it's actually favorable if you have no constants, right? We always don't want to have constants in expressions. So what I'm going to do first is actually create a new function, h of x, right, and define it as f of x times g of x. And the reason is, well, whenever you have two things that are being multiplied by each other, what is one powerful thing you can do to make any question a lot more easier, right? And that thing is if you're ever multiplying two things together, right? If one of those things is a zero, well, this entire thing is going to be zero, right? So anytime you multiply something by zero, right? This is a very common rule. The product is zero. And that's actually going to be very useful for us in this problem, right? Because that means we just need one of these. We want one of these functions to be equal to zero, right? Now, if you look at our functions, right, which one of these is probably easier to find when it equals zero? It's probably f of x, right? Because they're just less. There's no second degree term, right? It's linear in nature. So what you do is you set f of x equal to 0, right? Which means x plus p equals 0, which means x equals negative p, right? What that tells us is that if you plug in negative p for f of x, right, you get 0, right? Because you do negative p plus p, that cancels out to give you 0. So why is that important? Well, look at what we just found. We found that f of negative p gives you 0, right? So that means if you plug in, right, x equals negative p here, right, you first get f of negative p here, right? And we already know from earlier, right, that that equals 0. So this entire thing here is just 0, right? Now, remember how I defined the function h of x, right? If you're plugging in negative p for x, right, well, that means we're assuming that we're plugging negative p for h of x too, right? Because that's the input. So essentially, what you do is you replace x with negative p everywhere, right? So you do h of negative p equals f of negative p times g of negative p, right? Well, we know h of negative p equals 0 times g of negative p, right? Because once again, f of negative p here, we got earlier was 0, right? And of course, 0 times anything is just 0. So what that tells us, right, is that h of negative p is equal to 0. Now, why is that so useful? Well, because we know we know h of x, right? We know the exact expression. So what you can do is set this equal to 3, and just, right, and this essentially what I'm going to do is take every instance of x here and just replace it with negative p, right? Because that's still what we're technically doing, right? Because this entire function h of x. So if you find h of negative p, well, we're just plugging in negative p, right, to all these x's here. So now, right, that means plug in negative p everywhere. So you have negative p cubed. And make sure you put parentheses, right? So that's what we get, right? And of course, all of this is equal to 0. So what you'll notice is that this equation here, it only has a p. So, well, of course, if you use Desmos, right, we can actually find the value of p. But before I use Desmos here to plot the graph, I'm just going to simplify things a bit, right? Because we usually don't want parentheses when we're putting things into Desmos. So we can take this expression here, right, and actually simplify it. So we have negative 3p cubed plus 4p squared. And again, you don't have to do this. You can just go straight into Desmos and plug it in. But once again, this is what I do. So negative 3p cubed plus 4p squared plus 73p minus 90 equals 0. Right? And now what you can do is plug that into Desmos. And instead of using p here, I'm going to use x because, Desmos doesn't like that you include constants, like letters other than x and y. So here we have negative 3x cubed plus 4x squared plus 73x minus 90, right? And what you'll realize is that this graph here, right, it crosses the x-axis 3 times, which means there are 3 points, right, where the solution of whatever x is, like if you plug in x into this, you get 0, right? And you see that those 3 points are listed here on the right, and one of them is 5, 0, right? And that tells us that x equals 5 gives us 0, which means here, right, p equals 5. Because x was really just a placeholder, right? But p equals 5, that's answer choice C. So just to recap, right, the most important part about this problem is realizing that, well, you could go ahead and just multiply these two together, but that's going to take a lot of time, right? Because expanding, especially with multiple variables, is never a good idea. Um, that being said, if you only have one constant and you have to, and you're thinking of expanding, you probably can, right? It's much easier to deal with one constant when expanding. But here we have P, Q, and R, right? So the most important thing to realize is you have to use this multiplication uh, of these two functions and realize a very powerful and beautiful thing about multiplication, which is that if you multiply a specific term by 0, right, the entire product becomes 0. And you can exploit that single fact to get to your right answer here. So hopefully that makes sense, but please hit that like button and click on that subscribe. We post videos daily to help you on your ACT and SAT prep. So if you want to be notified, right, hit that notification bell so you are. But if you have any questions, leave it down in the comments, and I'll see you next time.